Hey guys, so the next few lessons are all going to be for chapter 10. It's all on different trigonometric formulas you need to know to help you solve problems. So the first four we're going to start with are the sum and difference formulas for sine and cosine. Do you remember with logs how we couldn't distribute a log through to the things inside the parentheses? The same thing is true for trig functions. If there's something inside the sine function or the cosine function and it's addition or subtraction, so you have a plus or a minus in the middle, a plus or a minus in the middle, you're not allowed, never, 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 take a trig function and distribute it through to the things inside. What you actually have to do is apply one of these formulas. So here's the two for sine and here are the two for cosine. These are all at the top of the page in your note packet. And over the next few examples, I'm going to show you how to apply each of them. Now, if you have the sine of two things added up, you're going to label the first item A and the second item B, the same with subtraction, and the same for cosine in addition or subtraction. And then you're going to apply the formula, substituting the A where necessary and the B where necessary. You don't have to memorize these. If I ever want you to use them, I'm going to give them to you. So in both of these formulas, you're going to see the letter A and the letter B, so for sine. And then in cosine, you're going to see that they're kind of mixed up. So just be very careful when you're applying the formulas, label everything as you go. So I'm going to start with showing you how you can use it to find things like the sine of 15 by using one of these formulas and not having to use the calculator. Now the hardest part to applying these formulas is figuring out which one you need and how you're going to apply it. So when I ask you to find something like the exact value of the sine of 15, you have to figure out what's on the unit circle that could get me to 15. Well, I could break 15 down into two angles that are in the first quadrant. For example, 15 I can get by taking 60 degrees and subtracting off 45 degrees. That'll give me 15 degrees. So if instead of taking the sine of 15, I took the sine of 60 minus 45, I would get the sine of 15 left over because the inside simplifies to 15. So what I'll do in my formula is make A 60 and B 45. Now I know you might not have thought like, oh, to break down the 60 and the 45 into the 15. That's okay, you'll get there with practice. You're trying to figure out what combinations will get you to the number I ask you for. So if I take the A and the B and plug them into the appropriate formula, 60 and 45, I know some information about. So let's do the sine of two things subtracted. So that's this formula right here, where A is 60 and B is 45. So following the formula, the sine of A is 60 degrees, B is 45, so it says the cosine of B, so 45 degrees, then a minus sign, then it says the cosine of A, so the cosine of A is 60 degrees, and then I have the sine of B and the sine of 45 degrees. So all I did was apply this formula, the one that my problem ran right into. And now those values are on the unit circle. So the sine of 60 degrees, you need to know, is radical 3 over 2 right off your unit circle. The cosine of 45 degrees is radical 2 over 2. Minus the cosine of 60 degrees is 1/2. And the sine of 45 degrees is radical 2 over 2. And all you'll do is simplify these using arithmetic. They're going to have a common denominator of 2 times 2, which is 4. Radical 3 times radical 2 is radical 6 minus radical 2. And you would leave your answer just like that. So when you're doing these problems, you're going to have to make sure that you can get your answer to as simple as possible, but I won't want you to put that into a calculator. That's what I mean by exact value. So let's do another one where we work the formula backwards. In this formula, I want you to find the exact value. Cosine 50, cosine 10. I believe they interrupted my lesson. We're going to keep going. So cosine 50, cosine 10, minus sine 50, sine 10. Well, when I look at this, I don't know 50 and 10. They're not from my unit circle. They're not special values from it. But 50 and 10 are 60. So I'm going to go over there to my formulas and see if I can get this to match anything. 2 cosines first, 2 sines second. Let's see, 2 cosines first, 2 sines second. So I know it's one of these two. And then the minus matches this minus. So I must need this formula in order to simplify. And if I kind of match everything up, 50 is the A and 10 is the B. So this is going to be equal to, working the formula backwards, the cosine of the thing I labeled A, 50 degrees, plus the cosine of the thing labeled B, 10 degrees. So that's the cosine then of 60 degrees. And the cosine of 60 degrees, we know, is 1/2. Now you have to do the same thing with pi's. So in this one, in your notes, this is labeled A and this is labeled B, just so you know. This one you're going to have to do with pi's. Pi over 12 is not on your unit circle. But maybe if I combine these, it might be on the unit circle. Sine cosine this time, cosine sine. Let's go look to see if any match. So sine first, it's going to be one of these two. Cosine second, okay, and a plus in the middle. So that's going to be this formula, where the A, it looks like A comes first, will be the 5 pi over 12, and B is second. I'm just matching these up to the formulas. So this will be the first formula, the sine. It's of A plus B. So A, 5 pi over 12, plus B, pi over 12, gives me a grand total of the sine of 6 pi over 12. Pi over 12 is not on the circle, but that reduces. So that's going to be the sine of pi over 2. And the sine of pi over 2, you do know from your circle, it's 1. So those are just a couple of quick examples of how to apply the formulas. So you guys keep looking them over, make any notes you have, and you can ask me questions in class. What I'm going to do now is erase and show you a couple more. Give me a second to erase. You look them over. Okay. So I just recopied my formulas over again up here so we'd have them. And I want to show you another one where we're simplifying the expression back to degrees. Now this one might not look like it's on the circle, but you have to try to match the formulas up. So if I make 105A and 15B, and then try to match this one up to a formula, it looks like I'm working with the cosine of A minus B. So this will be equal to the cosine of 105 degrees minus 15 degrees. And so when I simplify that now with subtraction, that becomes the cosine of 90 degrees. And the cosine of 90 degrees we know is 0. Didn't we just do this? The only difference between this problem and the ones we did on the previous slide were the directions. The last few problems said to evaluate or find the exact value. This one says simplify the expression. All we're doing is the same thing, the directions are different. But what happens when I put x's in there? Now this one's a little tricky. In this one, I have to go ahead and break this up separately, where this one uses the first formula and the second one uses the second formula, and we simplify. Pi over 4 is on our circle, so we'll be able to evaluate that. X is not, so you're going to leave the x in your answer. So I'm going to start by evaluating this one, where this will be A and this will be B in my sine of A plus B formula. So I'm going to look up there while I do it, and I'm doing the sine of pi over 4. Then it says cosine of B, which my B is x, plus the cosine of what I've labeled A, pi over 4, times the sine of x. And everything I just wrote is up to that plus sign. Now comes the plus sign, and I'm going to do the subtraction formula for sine on this term. And that one is right here. So I'm going to now make this A and this B in the different formula. So in that formula, it'll be the sine of A, pi over 4, cosine of B, B is x, and this one's minus the cosine of A, pi over 4, sine of B, which is x. And now you can either combine like terms if you have them right away, or evaluate wherever you see the pi over 4. I like to combine this now to make my life easier because I see a sine of pi over 4 cosine x and a sine of pi over 4 cosine x. I have two of the same thing. So that'll be 2 sine of pi over 4 cosine x. So when you see simplify, you want to try to combine like terms. I also see a positive cosine of pi over 4 sine x and a negative cosine of pi over 4 sine x. Those match. One positive and one negative. So those will cancel out, and you actually don't have to evaluate them. And so all you have to do to simplify is make this 2. The sine of pi over 4 is radical 2 over 2 times the cosine of x, and finish up your algebra where those 2's cancel. So your simplified version is the square root of 2 times the cosine of x. Now you'll see quite a few problems where you're doing this type of simplification. Maybe the directions will change, or you'll have to do something like prove and the answer will be given. This kind of goes back to what we did in the identity section a little bit. You're just using new formulas. So we're almost done. I'm going to erase while you guys look it over. Again, make some notes in your notes so that you can ask questions when you come to class next. And we'll just do 2 more. So the wording on these is just a little tricky. I move the formulas down here. Like I said, the directions will just change a little bit. They're going to want you to find all kinds of different things. In this one, you'll see right away, I'm going to need a formula because I have the cosine of alpha plus beta, just Greek A's and B's. So what I want to do is see which formula I need for that. It's that one, and then I'll see what I need from there. I'm going to ignore the rest of the problem to start. So to apply this formula, I know I need to find, again applying the formula, the cosine of alpha, you draw it like a little fish. And then it says the cosine of beta, which is the B with the tail. Then that formula says minus the sine of alpha, sine of beta. And now if you look at the original part of the problem, that's where I'm going to need some of the information. The sine of alpha and the sine of beta are given. So over in here I can put the sine of alpha, it's given to be 4/5, and the sine of beta is given to be 5 over 13. So I just replace those with what's given. But now I have to deal with what's over there. They only gave me the sine for both alpha and beta. I need their cosines also. So you kind of have to work this backwards like we did with inverses. So the first thing I'm going to do is work with alpha. They tell me alpha is between 0 and pi over 2. So I'm going to put a triangle between 0 and pi over 2. I know the sine is 4 over 5. Use SOHCAHTOA. So the opposite will be 4 and the hypotenuse will be 5. Use your triples and you know that the adjacent side is 3. If you can complete that triangle, you now know this angle is alpha in the first quadrant, like it says here, and you can now use SOHCAHTOA, adjacent over hypotenuse, to get the cosine. So the cosine of alpha is 3 over 5. Cosine of alpha is adjacent 3 over hypotenuse 5. Then you can repeat the process for beta. For beta, the other angle, they tell you that it's between pi over 2 and pi. That means that one will be in the second quadrant. And we'll do beta as our reference angle. Also, remember that's the same thing. And they tell me the sine is the opposite, 5, over the hypotenuse, 13. This is also a triple, 5, 12, 13. But do you remember what I have to do with that 12? It's in the negative x direction. So throw a negative in front of it. Using SOHCAHTOA, the cosine of beta then is going to be the adjacent. You need to know a negative 12 goes there, divided by the hypotenuse, 13. Remember, if you can't solve for one of the sides of the triangle using a triple, you would use the Pythagorean theorem to do that. So I'll substitute that in. Use parentheses, negative 12 over 13, so that you can go ahead and make sure that you know you're multiplying there. And really, you could be done. But we're going to go ahead and simplify. This is negative, let's see what I got there, 36 minus 20. 5 over 13, let's see, that's 65, I think. You guys go double check me. Let's see, 5 times 12 is 60, and then another one is 65. You know how my arithmetic is. So it's negative 56 over 65. And so you found the exact value of the cosine of alpha plus beta, and you had to go back to the chapter on inverses where we use the triangles. The last type of problem you're going to see in this section is an identity problem, just like we did in the chapter where we proved using the Pythagorean identities and the reciprocal identities and all those other fun tools from your toolbox. Just like in that section, I want to prove that this is in fact equivalent to this, but I can only work on this side. So this is very similar to example 4, where I'm going to call 3 pi over 2a and xb and apply the subtraction formula for the sine. So going on just this side, okay, don't work on that side, only on the left side, I'll apply sine of, let's see, a is 3 pi over 2. Then the next thing in the formula is the cosine of b, which I have as x, minus the cosine of 3 pi over 2 sine of x, applying that formula right there, with a and b being 3 pi over 2 and x. So now you need to know all of these values. So the sine of 3 pi over 2, remember how I do it off the graph, but if you needed to know from your unit circle, down here is the point 0, negative 1, and just as a review, this comes as cosine comma sine. So the sine of 3 pi over 2 is negative 1 times the cosine of x, minus the cosine of 3 pi over 2 is the x coordinate, 0 times the sine of x. And so that makes this entire term cancel. 0 times anything is 0. And so my answer is the negative cosine of x, which equals the other side. So in all of these problems in this lesson, I'm just showing you different ways to apply those 4 formulas. You have some homework problems that go with these that you can practice. And like I said, as I was erasing every slide, make sure you take some notes and write down any questions you have, and we'll go over them when I see you in class. See you then. Bye.